Hi, everyone. So very happy to be here. My name is Holt Skinner. I'm a developer advocate for Google Cloud, and today we're going to talk a little about Gemini 2.0 Flash on Vertex AI with Google Cloud. So just a little, oops, let me make sure I get my slides ready to go here. There we go. A little bit, well, yeah, there we go. This is who I am. My name is Holt, developer advocate at Google Cloud AI. I live in beautiful Austin, Texas, which, fun fact for today, it actually snowed across Texas today. For those of you who are not from the US and maybe not familiar with US geography, Texas is in the southern part of the United States, and it usually doesn't get very cold here. Sometimes it does, but we recently had a little bit of a snowstorm. I will say with big air quotes on that, which is a very different thing here than it is probably in the rest of the world. But we got 1 to 2 inches of snow. So here, a little image from. So my girlfriend and I got these little like snowball maker things, and so we made a little dino and a little duck this morning. It's very cute. And so, what do I do as a developer advocate? So I mostly focus on artificial intelligence and machine learning. And what I do is that I write a lot of code for other people to use. So a lot of things I end up doing are help software engineers use AI in their day-to-day lives. I create a lot of technical educational content, which basically helps software engineers around the world use Google Cloud AI products in their own work, in their own projects, and all of that. I work with our product teams to make them more developer friendly as possible. And I help build developer communities like this online and in person. So I end up creating a lot of videos, blogs, tutorials, labs, demos, and code samples, along with being the voice of the external developer in product engineering teams. And so I try to collect information from all sorts of users and developers to help best understand people's experiences, expectations about products. And I collaborate with our sales engineering team and consultants on customer issues. And I do things like Stack Overflow and Discord, all that sort of stuff. Okay, so a little bit of an overview of what we're going to do today. First, we're going to do a quick overview of Gemini. I have a question mark on that just in case people may already be familiar with what the Gemini model is. So we'll just we'll play it by ear. We're going to talk about some of the new stuff that just came out last month for Gemini 2.0. We're going to take a look at some learning resources well, just the code that you can look at for this. And then we're going to walk through some notebooks. We'll have plenty of time for questions, all that kind of stuff in here as well. So we're just going to kind of go through it. We're going to play it by ear, see how everything goes. It's going to be an exciting time here. So first, we're going to do a quick little overview of Gemini. So from the chat here, can you post in there, is anyone here not familiar with Google's Gemini model or anything in that space? Don't all speak up at once. Surely somebody here is unfamiliar with these things. There might be a little bit of a delay on the comments. Limited knowledge. Okay, excellent. Quick overview would be great. Okay, then. So we'll do kind of a quick overview of Gemini. So Gemini is Google's multimodal generative AI model, which means it can take in lots of different types of inputs. It can take in text, it can take images, video, audio, all that kind of stuff, and then output text. So it's a generative AI model, it's an LLM, all that kind of stuff. It works pretty much like every other large language model out there, like GPT or Claude or I don't know, Command R or whatever kind of model you use. It works very similarly. Most of them are pretty comparable. Some kind of differentiating features of Gemini. It has a very big context window of 1 million tokens. So it can take in an enormous amount of data. Overall, it can take in like large novels. It can take in, I think, an hour of video, 9 hours of audio, and a bunch of images. Some versions can actually take in twice as much, a 2 million token context window. And I pulled in some stats from this as well, just because people are always curious about these sorts of things. So from LM Arena, one of the Gemini models, Gemini Experimental 1206, released on December 6th, is actually the .1 ranked overall for language models. And then the ones that I'm going to be talking about today, mostly Gemini 2.0 Flash Thinking and Gemini 2.0 Flash Experimental, are So pretty high up there in the rankings. Gemini 2.0 Flash Thinking is actually, I guess, overall ranking tied #1 for with this other Gemini model and ChatGPT 4.0, and then Gemini 2.0 Flash is, I guess, #2 overall. So very exciting stuff. And it's also very straightforward to use. We're going to go through lots of learning resources to kind of get started with these. Now, something I kind of always need to do because Google has an interesting history of marketing this model. So, which Gemini are we going to talk about? There's a lot of different things that are called Gemini out there. It is a model. It's a web app. It's an integration, and there's multiple APIs that are involved with this. So, I'm going to kind of go through some of these just so that we kind of know what's going on with this. So we have the actual Gemini model is a generative AI model, or an LLM, as most people would know this as, which powers all these other tools that we're going to talk about here. So we have, of course, the Gemini web app, which used to be called Bard, and it's available at gemini.google.com. This is analogous to ChatGPT or the Claude Assistant, I think is what it's called. This is just, you go onto a website, you can type in whatever you want and get some answers. It actually has integrations into other tools like Gmail and Google Flights and Google Search. It should pull in like more relevant information than just the model itself. And so the actual model is what powers all the communication and stuff, but it has other tools and integrations into these other things. And then we have Gemini in Workspace, or Gemini in Cloud, or Gemini in Colab, or anything along those lines, which is what used to be called Duet AI, if you're familiar with the kind of old names of these. And this is integrations of the Gemini model into these tools that you might be familiar with using. So in Workspace, you can go into like docs and you can type in something, just whatever, into the doc. And then there's a little pencil mark where you can just say like, help me write this, or something along those lines. Or in Drive, there's some new features where you can get information from your documents and all that kind of stuff. And in Cloud, there's an integration directly into the Cloud Console, which can answer information about your specific Google Cloud environment, or about specific cloud products, all that kind of stuff. And then on the API side, we have Google AI Studio and the Gemini Developer API, which you can access at aistudio.google.com. And that's kind of the place we recommend people start with the Gemini API. And if you need to do anything production grade, or add other components or storage, or batch prediction or anything like that, then Vertex AI is what I would recommend using for that. Vertex AI is Google Cloud's end-to-end AI platform. And it has access to the Gemini API, as well as a bunch of other stuff like custom model training. There's feature storing. There's also Model Garden, which has access to a bunch of different partner and third-party models as well, including, I think, Claude is on there, Meta's Llama model is on there. Of course, all the Google models are on there as well. So there's a bunch of different options going on there. So just to kind of clarify some of these different APIs here, we have Google AI. Let's see here. I see a question here. I do not know much about Vertex AI. My first impression is kind of equivalent of AWS SageMaker. Same idea, yes. And I can give you some more resources on Vertex AI specifically as well. So AI Studio and Gemini Developer API is just an API that is for Gemini, and then Vertex AI is a full-powered AI platform designed for production use, enterprise grade, all that good stuff. But they both can access the Gemini model. And then we also have the Gemma model, which is an open source. It's an open source model created by Google, the same research team, the same technology as Gemini, but it's just completely open source. It's available on Hugging Face and every other place you can get open source models. So you can go to that website to access some of that model as well. So just a little clarification on that stuff here. And now, so we're going to get into some kind of new stuff here. So we have the Google Gen AI SDK. This just came out last month. It is a unified SDK that works with both the Gemini Developer API and the Gemini API on Vertex AI. So you can just change one-ish line to change between them. It depends on how you define one line and how your formatting works to say, but it's basically just one line. One function call is all you need to change. So for the Gemini Developer API, you can just put in your API key. And then for Vertex AI, you can put in, set this little flag Vertex AI equals true, and then put in your Google Cloud project and the location of it. There's also a new feature in Vertex AI called Express Mode, which allows you to use Vertex AI with an API key. and it lets you try it out, but it only works if you're brand new to Google Cloud. And so this works with Gemini versions 1.5 and above. There have been a couple different generations of the Gemini model. There's Gemini 1.0 was the first one that came out, I think, like about a year ago. Gemini 1.5 came out in about June or July of this last year. And then Gemini 2.0 is the latest version, which is what we're going to talk about for the rest of the talk. This SDK works with currently Python and Go, and there's Java and JavaScript coming in the future. So let's talk about the new stuff available for Gemini 2.0. These are kind of the latest and greatest cool features for Gemini 2.0 Flash. So Flash is just the fancy name of the model because it's super fast and it's also lower cost as well. But the quality is, very high quality overall. So the great features of this has better performance. It's faster than 1.5 Flash and higher quality than 1.5 Pro. I realized I kind of forgot to talk about some of these. So the previous generation of Gemini models, we have 1.5 Pro and 1.5 Flash. So 1.5 Pro came out first. It is the kind of like, it's intended to be the higher quality one, and it's a little bit more expensive. It also is a little bit slower. And then 1.5 Flash came out, and it's a much faster model, but it has a slightly less performance overall. However, Gemini 2.0 Flash kind of gets the best of both worlds. You get the high quality of 1.5 Pro and the high speed of 1.5 Flash. So there we go. And then, so there's also some new output modalities that have come out with Gemini 2.0 Flash, which includes the ability for the model to natively output speech and image. Now, unfortunately, these are only allow list for now, but these should be coming out to the public at some point soon. And if you are interested in getting access to those early, you can go to cloud.google.com/contact and get in contact with our sales teams. Or if you have a Google Cloud representative, you can request access for those. So Gemini 2.0 also has native tool use built in, which includes integration with Google Search. So you can get data from basically the entire public internet into your large language model queries. You have the ability to do code execution, which is pretty neat, and we'll look at more at that later. There's automatic function calling built right in. There's compositional function calling, which allows you to have like kind of nested function calls. There's also a multimodal live API, which is a bidirectional streaming API for multimodal input and output. So it allows you to have kind of live conversations and all that stuff with the Gemini model. And then there's thinking mode, which actually generates the thinking process, so to speak, of the model and gives it much stronger reasoning capabilities. Okay, so now enough of the slides and stuff. We'll look at some learning resources, the code that you can look at. Okay, so the biggest thing I'll be pointing you to today is the Generative Cloud Google Cloud Generative AI GitHub. There's a lot of G words in there, I realized. So this is the link for that. You can also use this QR code to go directly to it. This is a repository that is maintained by my team and I that is full of resources for how to use all these different generative AI models on Google Cloud. So there's models for speech recognition, speech generation. There's also Imagine, which is our image generation model. There's stuff for Vertex for search and RAG. There's conversational models, of course, language and Gemini, all that sort of stuff is on there too. And another great resource to look at here is the Vertex AI Cookbook. So if you go to this link or that QR code, it'll take you to this cool curated list of all these different notebooks and code resources for generative AI and Vertex AI. It's all hand selected by me from that repository, and it includes the highest quality notebooks made by Google Cloud DevRel and other Google employees. Yes, you can. Thank you very much for that, Ira, for putting that in the chat there. You can also click on that QR code, of course. And it has nice little cards with images for all the quick starts on key features. And you can also you can go to the list at the bottom and search for all the notebooks if you want something on a particular topic. But the ones that you'll mostly want to look at if you're getting started are at the very top of the page. So let's actually go into some demos and notebooks for all of this. So the three that I'm going to go over today are kind of the intro to Gemini 2.0 Flash. With the Python SDK, we'll go over the multimodal live API, and if we have time, we'll take a look at Gemini 2.0 Flash thinking mode. Okay, so you can access these from this link right here from Vertex AI Cookbook, and you can click on there. Okay, so let me actually show you what this page looks like. This is the page you'll go to if you go to that Vertex AI Cookbook link. And then you can click on View on GitHub to actually view the notebooks on there. So I'll show you what that looks like. It just opens up GitHub right here, and you can see, you can kind of get started with it. You can also click on these little links to open it up in various environments. I'm going to show them in Colab, which is Google's managed Jupyter Notebook environment. If you're not familiar with Jupyter Notebooks, they're a very easy way to get started writing Python code. I think it can be done completely free. It's just a nice little sandbox environment you can kind of play around in. And so I'll go ahead and switch over to Colab so we can actually run some of this and see how it works. Okay, so here's Colab. You can get to it by doing colab.research.google.com or by just clicking on that little link on that page there. So we're going to kind of get started with this. If you want to see a YouTube video that is made by this guy right here, I don't know who he is, but I guess he made some stuff about this. So it's a video that talks about, actually talks about Gemini 1.5, the previous generation, but it shows you some of the different ways to get started using Gemini with Google Cloud. And this is basically all the information I just talked to you about, but you can read it if you would like. So this is kind of an overview of what happens in this tutorial. I'm going to kind of walk through most of it here. We're going to do some text generation, streaming, multi-turn, asynchronous. We're going to show how to configure model parameters, system instructions, safety filters, control generation, how to count and measure tokens, multimodal data, automatic and manual function calling, and code execution. So first thing you have to do is install the Google Gen AI SDK for Python. It's pretty straightforward. You just do pip install, upgrade, whatever, Google Gen AI. I've already done that to save us a little bit of time. If you're running on Colab, you're going to need to run this little cell right here, which will actually pop up a couple of things here. I'm going to say, yes, I want to access my Google credentials. And you can't see the actual tab that's happening over here. Actually, I just have to click on a couple of little things. There's a little pop-up window that I just have to approve. And then once I do that, it should finish. Here we go. Yes, and again, if you're not familiar with this, all you have to do to run this code is just click on these little play buttons right here. We're going to import some Python libraries here, or we're going to import the library, the Gen AI library here. Okay, if you're using Vertex AI, then you have to set up a project and all that kind of stuff. There's a link that shows how to do that. Again, if you want to use this with the Gemini Developer API, you can go to, I think if you just literally do a Google search for like Gemini API key, and you can put that in there instead, and all the code will work the exact same. So I'm going to use my little test project here. Don't steal it, please. You won't be able to access it even if you tried that. And we're going to run everything in the US Central 1 data center, which is in Iowa, I think. It's decently close to me. And we're going to create a client, which is what everything else in this notebook is going to be run off of. Okay, and then so now we're actually going to use the Gemini 2.0 Flash model. This is the actual name of the model. You can also see the full list by clicking on this link right here. We're just going to load it into this constant of model ID right here. And yeah, that'll be used throughout the rest of this tutorial. Hopefully this is not too small for everybody. So let me zoom in just a little bit here. I'm going to close this out to give us a little more room so we can read everything. Okay, I'm going to load our model ID. And now we're going to do just some basic text generation. This is just like any other language model here. So all you have to do is do client.models.generate content. You put in your model ID and then the actual contents that you want to send in. In this case, we're just going to do a basic text query asking what the largest planet in the solar system is. And then we're going to print it out by accessing response.text. So we're setting the result of this into a variable called response, and then we're just going to do response.text to actually output the text. Now, by default, Gemini outputs all of its text using Markdown syntax. If you're not familiar with that, you can click on this link and it'll show you the actual specification for it, but it's a really easy way to print out what's formatted text. And so I'm using the display Markdown functionality from Jupyter Notebooks to make this work. Okay, and so there's a few other prompts that you can have in here if you want to just try it. And so you can also use streaming content here, which is so it'll print out little chunks as it goes. So it'll give you a response a little bit sooner. Now the thing about this though, yeah, so here we go. We got a response much faster from this, but it got to each little bit in a chunk here. So, and I'm printing this out this way until, printing it out with little dividers in between, just so you can see the difference in the chunks. If you're using this in like a chatbot application or something, you can print this out differently. But in Jupyter Notebook, we're kind of limited in the way we can edit this out. Just a little bit of a tip, just a little pro tip here. If you're just going to be printing this out in Python, what you could do is do print. We can do print chunk text, and then you can set end equals to nothing. By default, the Python print function will print a new line after every bit of text or after every function call. By setting this, it will have like no, it won't do a new line in between. So it'll print this all out in one big chunk. So let me show what that looks like. Here we go. So this is how it'll print out if you do that. So we have a nice little story about a lonely robot who finds friendship in the most unexpected place. Very cute. Okay, if we want to do a multi-turn chat, we can do that as well. All we have to do is create a chat object by doing client.chats.create with our model ID. Okay, that does nothing so far. So now we're going to send it a little message. In this case, we're going to ask it to write a function which checks if a year is a leap year. So we're going to ask it to do some code generation. And it's going to print out our response. It's actually taking longer than I expect. Here we go. So we printed out some code, and it displays it, in the code font and all of that up here. It gives it a little explanation, all that kind of stuff. So now with chats, it maintains the context between each message. So you can actually use the context of what you just put in to ask it for more information. So you can say, we wrote this code right here. We also wanted to write a unit test of the generated function, and we'll print that out as well. Yeah, so code generation takes a little bit more time than some other things because it's got a lot of thinking to do. There we go. So it just wrote a unit test for all of that, which is much faster than I would be able to write this, in all honesty here. And it gives a little explanation of what all's going on with it too, if you want to read that. Okay, so there's also some asynchronous methods that are available on our client, which is just if you want to use async IO or some other asynchronous framework or something like that. All you could do is do client.aio and then models.generate content, or whatever method you're going to be using. It all works the same way here. And most of the time, you probably won't need to use this. It just kind of depends on your own use case. So we'll just show you how that works if you're curious about this. In this case, we're going to ask Gemini to compose a song about the adventures of a time-traveling squirrel. So it's very cute. We have a little, he landed in Rome with togas galore, nibbled on figs outside Caesar's door. It's actually decently creative there. I like it. Okay, so you can also configure some of the model parameters. These are the different knobs and switches you can adjust to change how the model might respond to different questions or to different prompts that you put into it. There's actually a whole documentation page here that talks about parameter values and what you can do with that. So you still use the same generation method right here and the same model. You put in whatever prompt you want, but you have this little generate content config class that we imported at the very top. So you can adjust in different parameters like temperature, which is the degree of randomness of the response, top P and top K, just choose how the tokens, like the actual text, are selected. Again, most of the time you probably don't need to adjust these. It's kind of just, we give you access to all of these different buttons and knobs just so you can change them if you want to kind of experiment with that. But this page does tell you what these pages tell you what these different parameters do. We have a seed value, which lets you, it kind of also controls and limits the randomness of it. So if you know about random number generators, they usually have a seed in there. A lot of times it's generated by time. This lets you kind of hard code that in so you can, in theory, get the same response for the same prompt every time. Now, even when you put this in, it's about like 99% or so. There's still some possibility that it may not always give the same response, but that's true for pretty much any generative AI model out there. You can set max output tokens, which limits the amount of text that it outputs. You can put in stop sequences, which just, it's if the model outputs a certain string of text. In this case, we put in stop in all caps, but you could put like, I don't know, you could put 3 hyphens or something like that as a stop sequence, and it just lets the model stop early. And then there's frequency penalty and frequency, sorry, presence penalty and frequency penalty as well as options. So let's actually see how this affects our response. So the one that you could definitely see the most here is that the response is a lot shorter than all the other ones. And that's because we set max output tokens to 100. If we put this to a higher value, like, I don't know, 5,000 or something, we'll get a much bigger response. And the maximum output tokens, I think, is around 8,000 for Gemini 2.0 Flash. But that's changing kind of all the time. And you can read on these pages to see what that is. Here we go. We have a much bigger response now. We can also set system instructions, which lets you steer the behavior of the model. It's kind of just giving the model additional context. And you can also, this is whenever you give it like a persona or something like that. So it's kind of sent in before the rest of the prompt. So it kind of defines what the model is going to act as and how that is going to work. So for example here, you are a helpful language translator. Your mission is to translate text in English to French. So this one we're going to say, I like bagels, and see how it responds to that. So I'm not going to try and pronounce this here, but that is what I missed. That is, we have had actual translators verify this, that this is accurate in French. Okay, we can also put things in like safety filters, which is part of our whole push towards responsible AI. So this is all about limiting, I guess, bad responses by the model. So you can actually set these manually. There are some defaults put into place, but you can put in things like dangerous content, harassment, hate speech, explicit material. So you can limit it to, say, like block different thresholds of like low and above, or we can put high and above only, or you can actually turn these off if you're working on something particularly sensitive and everything gets blocked. You can actually read more about this on the safety filters page to kind of understand more about what these are doing and the different ways this is all measured. And so you can actually see how the response is different here depending on this. We're going to have it write a list of 5 hateful, mean, and respectful things that I might say to the universe after stubbing my toe in the dark, which happens more often than I would like. So in this case right here, it actually didn't block anything on here because we set it at low and above. We could actually turn this on. That's interesting here. It has our probability scores pretty low. The severity scores are pretty low as well. They're considered negligible in this case. I could probably ask it for some more, some more mean things that would actually block the response here. That's actually very interesting here. So technology is always changing, because last time I ran this, it actually did not give me any response for this. So it blocked everything. But you know what? Things don't always go the way you expect when you're doing live demos. That's how you know this is real. So let's keep on going here. So we're going to take a look at some multimodal prompts here as well, which is where you can send in things like text, code, documents, image files, audio, and video. So what we can actually do on here is we can take in, say that we're going to download this image from Google Cloud Storage here, which is just I think just a picture of some food or something like that. We've copied it locally here. And I think I can also print this out here. So if I do display, and then I might have to import the image file. So from IPython.display, import image. I think that's the right thing for that. Display image. We can actually view this if we want to. Let's hope this thing works. I might get my syntax wrong. Oh, whoops, sorry. Let's hope it works here. Haha, we can actually see what it does. So we pulled in this is simulating a local image file that we're putting in. So we're going to read it in using just the regular Python file opening syntax. And we're going to say, write a short and engaging blog post based on this picture. So the way we send this image in is we use this part class, and we say from bytes to say that we're doing a local image here. So we're reading in just the bytes from the file as binary. And then we have to send the MIME type, which if you're not familiar with, it's also called media type. It's just telling, this is a common internet protocol. It's just telling the service that we're sending this to what type these bytes are, so it knows how to read it properly. So let's see what our short and engaging blog post based on this picture is going to be. So we're sending our API request to Gemini, and then we're going to get the response. Nice. Meal prep magic. Conquer your week with these delicious bowls. Okay, so this isn't about bland, boring food. Look at these vibrant, delicious bowls. Oh my goodness, so exciting stuff. The possibilities are endless, indeed. Okay, so we can also do this with some documents from in this case, I'm going to send a PDF document from Google Cloud Storage, which is Google Cloud's cloud storage option. It's blob storage, if you're familiar with that term. It just lets you store basically any kind of file. In this case, we're going to do some document summarization here. We're going to pass in this document, which I believe is a paper made by DeepMind about the Gemini model. Oh yeah, here we go. This is it's the attention is all you need paper, which is the paper that kind of created the transformer model, which is what every large language model is based upon. And this was created by Google Brain, which is now part of Google DeepMind, and the University of Toronto. So it gives you kind of a summarization of it, the key points, and the overall significance, and all that kind of information. You can actually ask for more specific information about it as well. We're also going to load in data from a general URL. You can load, let's see, audio or documents or whatever from just any URL from the internet, as long as it's publicly accessible, and Gemini can read it. So in this case, we're going to have it write a summary of the podcast episode that is in this. This, I think, is from the Kubernetes podcast. I'm going to blow my nose while this is running here. So we just got a summary of the podcast here. We have a lot of nice information from that. So it's talking about the highlights of KubeCon North America 2024. I'm not a Kubernetes person, but I'm going to guess this is pretty accurate for what all is in that. We can also pass in YouTube video URLs, which is pretty exciting here. So this is I think an ad for Pixel or something like that. Oh no, it's Google 25 years of search. And so the prompt I have in here is, at one point in the video is Harry Potter shown, because this video does have a little clip of one of the Harry Potter movies in there, and I love Harry Potter. So it'll actually be able to kind of search through this whole video and see and give us an exact timestamp of when that is. So it's got to read everything in, and we'll see what it tells us. There we go. It shows us that it's at timestamp 56 and 58 in the video. Let's actually see if that's right, just for funsies here. Let's see here. There we go. Yes. So the timestamp might be like, 1 or so second off, just because of the way that YouTube manages these things. But here we go, 57. And here's another one, 59. It's, I think, just 1 second ahead, or the YouTube video shows it as 1 second ahead, but same basic idea there. If you were searching for something in there, this is enough to get you where you need to go. Okay, the Multimodal Live API, we're going to show another notebook that shows how to do this and everything. It's built on the WebSockets protocol, so it shows you how to read it to input and output audio, text, video input, all that kind of stuff. So the model itself can also do what's called controlled generation, which allows you to define a specific schema to specify the structure of that model's output. So this is really useful if you want to communicate with other tools, or if you just want to, if you're doing something like document processing, especially, if you want to get everything out in a specific format. So it's really easy for your post-processing to read it. So you can actually pass in pydantic models or a JSON string, and then the model will respond either as a JSON string or an enum. You can also set it to do that. And you can actually parse this out. You can either parse the string directly as JSON, or there's actually a field that you can get that response out as an object or a dictionary. So let's import pydantic base model. We've created a custom class here for recipes. And so what we're going to say here is, we're going to prompt Gemini to say, list a few popular cookie recipes and their ingredients. And then in our generate content config, we're going to pass in the response MIME type as application JSON, which I've learned that most people say JSON, but I don't know, I prefer saying JSON. That's what my web development professor in college said it, and I'm just so used to it at this point that I don't want to change it. And then we pass in our schema, which is recipe, this class we created earlier. So then if we print the response text, instead of printing out like, yes, sure, here are some popular cookie recipes, blah, 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 it actually passes them, it returns them all in the specific schema that we gave it. So it's going to give us a description, it gives us our ingredients as a list of strings, and then a specific name. Then we can either use the JSON library in Python to parse that directly and bring it into a dictionary or something, or we can use this response. The response is what we got from the model, response.parse, and it actually creates an instance, it creates an object, an instance of this class that we can use directly. So we can also do like print parsed response dot name and then get that specific field out. Yeah, so we can get chopped cookies out of that, or whatever else you want to do. Okay, you can also define this schema as a Python dictionary. These are the different types of fields you can do. This is the open API specification. If you prefer to use that for whatever reason, you absolutely can. And I'm not going to go and run this just for time's sake. We're going to keep on going. So you can also use this count tokens method to calculate the number of input tokens that you're going to be processing before sending a request to the Gemini API. So this is especially useful if you're trying to cut down on cost or something like that, or if you just don't, if you have like a really large video or something, and you want to know that if it fits in within the context window or something like that. So this one doesn't actually process that, it just tells you how many tokens there are. So tokens are just the way the model chunks up the response that you have to process it. So you can do that. And then compute tokens is a different method that only works on Vertex AI. It runs a local tokenizer instead of one through the API. So it's gives you lower latency because it'll run everything locally. It'll give you the same answer either way, but this also does give you the specific token IDs and the tokens themselves if you want to have that information for whatever reason. Okay, so search is a tool which used to be called grounding, and it still is in some of our documentation. This allows you to actually connect in Google search results into the Gemini model. So for example, you can actually get like you can get more up-to-date or more accurate information than what is just built into the model's training data. So what you can do here is define a tool that has Google search in it. And then all you have to do is pass that in to the generate content config, the config object, pass in our tool that we created. We can ask our question, which in this case, when is the next total solar eclipse in the United States? Then you can actually print out the response and see what it gives you here. So it says right here, the next total eclipse in the United States will occur in March of 2033. That's in what, 8 years from now, I think? No, yeah, somewhere around there. But it's only visible in Alaska. The next total solar eclipse that will be visible in the contiguous United States is in 2044. That does sound about right here. And that tells you when the most recent one was that crossed over the United States, Mexico, and Canada. And then you can also print out the grounding metadata as well, which actually gives you like the actual sources and citations for all of this. And you can click on this link and actually go to the original source if you want. So this is where it took me to. List of solar eclipses visible from the United States on Wikipedia. Seems pretty legit. There's a few other things in here, like from space.com, which sounds like a good resource, greatamericaneclipse.com. You can print all those out, or you can just use that to kind of cross-check this information. There's also this search entry point thing, which is if you're going to use this feature in your own applications, you have to print this out just to show that, hey, these results are coming from Google, I'm using them. And so you can also connect this information. You can connect Gemini into your own data by using another product called Vertex AI Search. So you can load in your data into a data store. This can be your documents, or this can be structured data or websites, all that kind of stuff. And then you can connect that into Gemini, and it will do a query to that information it'll do a query into that information in there before generating a response. It'll load all that data into the prompt and output a response based on all that information in there. I'm not going to run this just because it'll take me a little bit of time to actually get this information right now, but you can follow this Get Started guide, which I actually wrote as well, that shows how to create a data store in an app, and then you can add the data store ID created into this little code cell, and it'll do that. This is one of the many ways of doing retrieval augmented generation, or RAG, on Google Cloud. So function calling is another cool feature that you can use. This is great for whenever you want to connect your own code into Gemini for whatever thing. So if you have an API that you want to get live information from, then you can pull that data in from the API, and it'll it'll inject that data into the Gemini prompt, and then it'll give you an answer based on that. So the easiest way to do this is just write a Python function. This is part of automatic function calling. All you have to do is just write a Python function. You do need to add a doc string and put in typing and all this kind of stuff to make it to make it all work the best way possible. So we're going to say get current weather. This is just an example method. Let's say it's calling some kind of API. We're just going to get a random answer because that is entirely how the weather works. And all we have to do is pass in that function as a tool into Gemini. We're going to set the temperature at 0, which gives it a theoretically deterministic response for all of this. So we're going to run this. In this case, it picked the random answer of, in Boston today, it is snowing. Okay, we could run this again and it'll give us a different random answer. But actually it gave us the same one in this case. But let's see how many times I do this. Now it's sunny. If we were doing this for real, it would call a real weather API, but we don't have that set up on here just for simplicity of the example. And then you can also pass in an open API specification of a function if you want to do manual function calling, which it's a couple more steps, but it gives you more control about when that function is called and where it's called. If you want to, say, call one of your specific APIs, or if you have multiple different servers that are running these kinds of things concurrently, you can control all of that. But it is a little bit more difficult to do. And now here's the code execution feature, which is pretty neat here. So it allows you to generate and run Python code, currently only Python, and it can actually learn iteratively from results until it arrives at some kind of output. So what it'll do is you can have it generate some code, and then it'll actually run it and make sure that it works. So that's pretty neat. So what we can do here is we create our code execution tool right here. And then we're going to plug it into our Gemini API call here. We're going to say, calculate the 20th Fibonacci number, then find the nearest palindrome of it. Sounds pretty complicated. It sounds like a great leak code question. I would not enjoy doing that personally, but it's something we can have Gemini do it for us if we want. So we're going to run this, and we're going to print out the language of the code, which currently is just Python, but in the future, this will be expanded to other languages. Here we go. That was actually very fast. Cool. So it prints out the language as Python, and then we have our executable code right here. The actual code is right here, and then we can actually see the execution results are printed here as well. So we have the outcome, which is outcome okay. Yes, it worked correctly. And then the actual response was, so our printed out output was, let's see. Yep, so diff1, the absolute value of Fibonacci 20 minus palindrome 1. Yep, so we actually see the differences between all of these here. Diff1, 11, diff2, 99. So I think, what do we say? Find the nearest palindrome to it. This is the way of finding the nearest palindrome of it. Yes. So it's finding nearest as in like the one that's closest in number. So we have our 20th Fibonacci number is, here we go. 20th Fibonacci number is 67, 65, and then palindrome 1 is this, palindrome 2 is that. I think it ran it maybe another time on a different, some different data. Very nice. And then there's also some great features of like spatial understanding and object detection capabilities. We have some other examples in the Gemini cookbook, which is for the Gemini Developer API. And we have some for 2D spatial understanding and 3D spatial understanding with Gemini 2.0. So these are some really cool ones. You can go in here, click on it. It'll take you directly to the notebook, so you can try it out as well. And the code will also work the same way on Vertex AI. You just have to swap out this initial SDK initialization here. So there's just a couple of different ways to handle that here. Then we have some other resources in here if you would like to take a look at those. I realized I took a little more time than I expected on this, so we aren't going to have time to go through these other notebooks, but I'm going to take this time for question and answering. So if you want to try these out for yourself, I recommend going back, make sure I get that link back on here. So goo.goal/Vertex AI Cookbook. Let me actually go back to that page so you can see this. The other ones I was going to go through were getting started with the Multimodal Live API and getting started with Gemini 2.0 Flash thinking mode. So if you want to try those out, they're completely free to access. And I think actually all the Gemini 2.0 model is completely free to use at this point. There's no charge for it until it goes generally available. There's also a bunch of other examples in here for showing some that go more in depth with how to use function calling, some with grounding, prompt engineering. Batch prediction is something we didn't even touch on that allows you to run predictions on a large number of examples which is really cool. Some examples of the long context window, context caching, which I didn't even show that yet. That's a way to cache that long context window to make it cheaper and faster to make concurrent calls. By the way, if you're currently using OpenAI, you can also call Gemini using the OpenAI library directly. You can use their chat completions API, and you can just change the endpoint and try out Gemini in your applications if you're already using OpenAI. So that's pretty neat. And there's a bunch of other examples in here for different things, some for specific industry use cases, some using speech and text models. We have some for podcast episode generation, which is very neat. LLM security, if you want to know more about prompt injection and those kinds of things. Document processing, RAG engine, which is another way of doing RAG on this. And then, of course, you can search through all of these and filter them to view whatever you want to on this. So there's hundreds of examples here. I think we're up to like 200 or 300 notebooks that show how to use Gemini and generative AI models in Google Cloud. Okay, so I'm going to go into the chat, and hopefully there are not too many questions that are super overwhelming, but we shall see here. So we have, actually, okay, this is a reasonable amount of questions here. So I'm going to change my slide over to questions so we can be very clear that that's what we're doing.